Hello, everybody, and welcome to Rails School at Noisebridge. Today, we're going to talk about processes, threads, and fibers, some of the very most primitive concurrency abstractions we have in Ruby and in programming, in Unix programming. My name's Gabe. I started this class a few years ago and have been lucky to have some volunteers join me, like Brad and Donald. Good to see you, gentlemen. Hope you had a wonderful Thanksgiving, everybody. And we are all super grateful to Noisebridge for having us. Please be respectful of the space and grateful and give money. Suggested donation is $10 a month. And if you go to Noisebridge donations website, I'm going to share my screen quickly. You can set up a recurring donation, which is really the most helpful thing you can do, because then Noisebridge can count on your $10 every month and figure it into their budget so they know that they're going to be able to make the rent. We have a link to this from our FAQ, but it also comes up in Google, so you really have no excuse. There's an anonymous Bitcoin address on this page, and there's a bucket up front. Great. So if you're new today, be aware that we have a website, railsschool.org. And on this website, if you click on the class page, there's a button. You have to be logged in to see this button, but it's free to register. We don't ask for any personal information. You can click Show Whiteboard, and that's what I have in the other tab. And the whiteboard is just an Etherpad. It's like a lightweight Google Doc that's really handy for sharing links, and somewhat handy for sharing code snippets. But everybody that's logged in can read and write this pad. So you might find it useful to log in and join the pad so that you can copy links that we post here and possibly copy code too. Cool. So returning volunteers, I already shouted out to y'all, but welcome Brad and Donald. And I feel like the three of the non-volunteers, I feel like you all look super familiar, but I don't know any names. So I'm going to go ahead and ask. Raise your hand if you've been here before. Okay, so we do have one new person. It just looks familiar. Maybe it's your Elixir sticker. New student, what's your name?
David.
David, what's your experience with programming, and what do you hope to learn, not just from today's class, but also we hope to see you at future Rails schools. So tell us what you're seeking to gain from participating in the class.
I don't really know much about Rails school itself, but this class sounded really interesting. I'm learning Elixir, so the whole concurrency aspect really sounds interesting as well. What else? Maybe some meta-programming stuff.
Cool. So would you say that you already know a little bit more Elixir than you do Ruby?
No, I think I know more Ruby than Elixir, but I don't know any concurrent Ruby.
Sure, but you're moving fastward with Elixir. That's what you're focusing on?
Yeah.
Very cool. For those of you that don't know, Elixir is it's also the programming language that I'm learning, and the reason it's so attractive is because it leverages a somewhat esoteric virtual machine that's been around for decades and powers all of a lot of cell phone and other like networks, WhatsApp, where you have a lot of messages, a lot of throughput needing to go different places. So it's sort of a proven virtual machine. And on top of that, it's called the Erlang virtual machine. On top of that, we have Elixir, which was invented by Jose from Rails, which has a sort of a nice API that we like a lot. So check it out. And there's a framework, a web framework for Elixir called Phoenix that Jose didn't invent, but he basically is working on it now alongside Chris, who invented it, and it's pretty rad. In fact, Rails is starting to steal from Phoenix already. If you keep your eye out for Rails 5, I forget what they call it, but they basically stole the notion of having WebSockets work out of the box.
Is it the action cable?
Yeah, Action Cable. Thank you. Rails is calling it Action Cable. It's coming to Rails 5, and they basically were inspired by Phoenix and its channels and what is it, Phoenix.js file that it comes with it. So you can just, out of the box, you have free, highly concurrent web request handling. It's really nice.
Rails 5 coming? It's supposed to be fall this year.
Yeah, let's look it up. Rails 5 is exciting. Why is Rails 5 exciting? Let me know.
Based on API, or Rails API.
That is cool. They merged in Rails API, so you don't have to decide, am I building an API or am I building an app? You have all that built in. What's exciting to me is that it breaks backwards compatibility with Ruby less than 2.1 point something, which means it's the maintainers of Rails can sort of relax and not fuss with all this nonsense. They can remove a bunch of cruft, and also they can take advantage of certain features like garbage collection of symbols, so they can remove a bunch of code that has to deal with preventing denial of service attacks from memory overflow from symbols. So it can be faster, which is awesome. And we all get that for free as long as you're using a relatively new version of Ruby, which many of us are. So we're really excited about that. So API, faster, and also it means the whole ecosystem can start targeting Ruby, the newer versions of Ruby. If you have a gem that you're trying to support, you can sort of assume that you can say, hey, I support Rails 5, and you know that everybody's bringing a relatively new version of Ruby. And then Action Cable, last time I looked at Action Cable, it was like super unspecific, super vague. Like it was just something that was promised. Do you know anything more? Or no. So theoretically, Rails is going to support WebSockets out of the box without needing to run a separate server manually.
The new turbo link.
New turbo links. I wish that would just die already, but it won't give up.
TurboLinks is cool.
It's cool. I'm sure I'm missing out. The new TurboLinks is like more sophisticated. So,
That's cool.
Hey Joe, welcome.
It's just annoying to start.
It is. I'm especially annoyed because if it turns out that TurboLinks 3 is super awesome, that means all my apps where I turn TurboLinks off, I have to like figure out how to make them work with 3. Oh, and Ruby 2.3 is coming out. It's scheduled for Christmas. And nothing super major there. It's getting a little bit faster. There are a couple of cool features that you should check out. All right, Rails 5. They're hoping to release it. Maybe there's a beta already on RubyGems. Let's see. You have to click show all versions to see the betas. There's not yet a beta on RubyGems, but maybe by Christmas, that'd be pretty cool to see have a beta. I usually don't play with them until they release it on RubyGems, but if you want to, you can use it from Git. Cool. Welcome, David. I think we've only done one class on Elixir ever here, and we should totally do more. And I'd love to get you involved if you'd be interested in doing just even one that's like very like introductory, because that's all I've ever done, and that was over 2 years ago. And to be honest, I haven't done enough Elixir, very much Elixir recently, but I would definitely come out. And I'm sort of bullish on Elixir. Seeing what's going on in Phoenix and seeing how it's like very rapidly reaching parity with Rails, super exciting.
Already?
No, Rails, it's going to take a while. Rails is pretty awesome, but it's moving fast. And they're smart because they're a bunch of old Rails people, so they're just stealing everything good from Rails, which is great. But they don't have to deal with all the legacy crap, so they have there's a little bit of advantage there. on the way. And it's way better at concurrency. Like what we do today is very, like, you got to know this stuff because it's the same in Python. It's the same in C. It's the same in a bunch of languages. So you got to know it anyway, but it's not really where we want to be. Other languages like Go and Rust and Elixir are a little bit more hip, which is actually what provoked me to schedule this class. Is what I really want to talk about is like more fun concurrency stuff. But I figure we have to cover like the basics first. And by more fun, I mean like, stuff I would actually use. I often use like an event pattern in Ruby. You can use gems like Event Machine and Celluloid, for example. There's cool little ecosystems around that. It's definitely fun to learn, and you can actually use it in production. But I don't think it's smart to jump right into that stuff before covering the basics. So returning students, I'll pick on Joe since I know Joe's name. Joe, what's your background with programming, and what are you hoping to learn today and in other Rails school classes?
All right, my background in programming is way back when the Flintstones were chiseling out our punch cards for us. And we were chiseling out punch cards and running them on IBM mainframes, which seems like centuries ago. I learned Fortran, and I've been a middleware programmer, and I still use a chisel and punch card if I can get with it. And that's my background. I'm learning quick classes like this to get used to UX UI. UX UI is you run a program from a terminal, type in a line with a bunch of switches, and it runs a program and it makes a file for you, and you go from there over and over and over to get your output. UX UI graphics is like, huh? So we got to learn it sometime, right? So that's my background. Done.
Welcome, Joe. Some of us know Joe from Railsbridge, which has been doing workshops for women and their friends since I moved here 4 years ago, and it's pretty cool. And they need help. You should definitely volunteer. Is there an Alex in the room, or is the Alex online? Hey, Alex, does your microphone work, or can you just punch in to the Etherpad a little bit about yourself? My microphone work? Yeah. Okay. We'll come back. Oh, there's Alex. What's up, Alex? Cool. Welcome, Alex. Glad to see somebody taking advantage of our stream. Hopefully it hangs in there. Yeah. We're crossing our fingers. Something that you folks can help me out with is if I'm alt-tabbing around and you see Alex asking a question, since his mic is off, just raise your hand or grab my attention. Otherwise, I'll miss it. So we got David, the volunteers, Joe, and I'll start with you. You have been here before, but
it's been at least 6 months. I'm Anthony.
Anthony.
Yeah, I used to work with Brad for a little while. We go way back. I started coming here like over a year ago. Maybe like a year ago. But it took some time off. And I actually worked with Railsbridge just like 2 weeks ago. I helped them out with their latest class. And I just go to things and learn things. And I just want to learn.
Awesome. Well, good to see you again. It's a very rewarding part of doing these classes is seeing people come back after, because we don't
every week. And then it just work. Gets it.
Totally. And this is something, if it's not clear, David, like this is all volunteer driven. So we teach what we are interested in / what we think is interesting that we're capable of teaching / what people are interested in. So it just comes and goes, the different topics, which is why you shouldn't feel any pressure to show up for 6 months if you can't, or if the topics just don't interest you. And at the end, we'll ask you for topics that do interest you. But that's part of how we define ourselves. It's like we don't ask very much from the students. And the students don't ask very much from us. But we learn. We were very disciplined, and we learned a lot and have fun. All right, you're last. Sterling, with an E.
Yes.
Cool. And would you remind me what your background is and what you're learning these days?
Like 2 years ago, I didn't know anything. I started in this class, and now I know more stuff.
Awesome. Great. And I want to give a shout out to Alex for doing the Code Wars. This Code Wars is not particularly relevant for the topic, but it's fun to see people do these because the software on Code Wars is pretty cool. It's a pretty slick website, and there's a little bit of a community over there, and it's gamified, and it's sort of we're really happy partnering with them, sort of seeing how Rails School can offer more to our students. So we do try to pick out exercises every week, and especially this week, not super relevant, but it is cool to see that you did it, Alex. Special shout out to Alex. All right, cool. So as like a little outline, before we start hacking, we do want to summarize each of these things, process, thread, and fiber. Really quickly, they're very similar. Hello. They're very similar, but also different, and that's why they exist. That's why there's not just one abstraction. We have three. And the first two, process and thread, are in this case, provided by the operating system. And there's like a specific term for the threads that are provided by the operating system. I jumped to threads. I'll come back to processes. Does anybody know that? Does anybody know? It's like a popular Python web server that has the word unicorn in it. Yes. Do you know what the G stands for? To color. Your shirt. The other color. Green. Green.
Green.
I don't know. You can look on Wikipedia why they're called this. But threads can come in different flavors. And the specific term, I believe, I may be wrong, for when you're using threads that are provided by the operating system is green threads. And that's what Ruby has. Processes, I'm going to say in most cases, and in parentheses, like Elixir basically redefines the word process. But I think everywhere I've seen outside of Elixir, process basically means one thing, which is provided by the operating system. And a fiber is not specific to only Ruby, but it's not something that's provided by the operating system. Oh man. Well, I'm actually operating this Etherpad server, so I'm glad it came back. That would be embarrassing. Fiber, not provided by operating system. So that's good. Oh, I lost something up here. What else do you in the room know about these things? Just name random stuff that you know about them.
I read something about multi-threaded versus singular threading.
Some Ruby web servers run on a single thread, but some run subsequent requests on multiple threads. You and I learned that even WebRec does that, right?
Yeah, and there's a word for whether or not you should expect your program to have bugs when you run it multi-threaded. Yeah. I'm not gonna like get caught up in defining these things, but that's all that thread safety means. It means if I run this program with multiple threads, is it gonna have tons of bugs? Because the threads are stomping on each other's state that they share, typically. And Rails was like Rails core, like the Rails itself was not thread safe for the longest time. And when something's not thread safe, say you couldn't use a thread, you're running Rails. Do you know what we were using at the time when Rails wasn't thread safe instead of a thread of these three? Yeah, you can use another process. And the reason is that processes, this is very fuzzy but meaningful, share less stuff than threads. That's why you get away with it. Threads share more stuff than processes. And somebody that knows like a little bit about operating system, why are processes so important and cool? I'm sorry?
That's like the program itself is like the process holds the actual running program itself.
And why is that important? Like on this computer, how many, guess how many processes are on this computer?
Hundreds, yeah.
I'd say probably hundreds. You can,
They're somewhat isolated from each other. They go up already.
I guess,
But you can't tell.
first one is lines, right? Yeah. So 201. Eyeballing it. So hundreds. These processes are diverse, right? Some of them are owned by the operating system. Some of them are not. Like I've got a Chromium process here, right? Like conceivably, I can launch Iceweasel, which is Firefox by a different name. We've got the developers of Chromium. We've got the developers of Iceweasel, and both of their software are safely runnable on my machine, and they can't interfere with each other. And what I'm getting to is we have a term for to describe the process model that's kind of cool to think about, and that is they're fighting each other. What's the term? The antonym is cooperative. Thank you. Competitive resource sharing. And this was invented like at least in the 60s or earlier, but it's super rad because it basically means that the operating system is the referee and just lets them have at it. And the developer of Firefox doesn't have to like walk on eggshells like, I don't know, I might mess with Chromium. Like they can just take as much as they can get and rest assured that the operating system is going to cut them off if they take too much, or just basically transparently share the resources, right? And I'll go ahead and say fibers are basically basically lightweight processes is what you'll hear. And fibers are explicitly cooperative. So that means that they're more overhead for the programmer to use than, I just said fibers are explicitly cooperative. They're more overhead for the programmer. With the competitive processes, our job is very easy. Just use the resources. Use anything you can get and don't worry about it. once you are using a cooperative model, you have to do it right. You have to make sure that if you have two threads, that one of them does some work and then lets the other thread do some work. Otherwise, one of the threads could just use all the resources, right? And by the way, I'm skipping some fundamental stuff, which I hope you'll forgive me. But I think you all are filling in some blanks in your heads, which is great. And my question is like, to what extent are threads cooperative or competitive? They're provided by the operating system. I believe that they are competitive. We'll double check this. So then what gets interesting is what's the difference between a process and a thread? Anybody know?
Isn't a process made up of threads? Like multiple threads in a process?
That's a common model. Yeah. Can have multiple threads. Definitely. All right. Processes are both provided by the OS. They're both competitive. They share less stuff. Can we articulate like what some of the stuff might be that they're sharing less of? Memory. Share address space with sibling threads. And processes have isolated address space. So threads are competitive, but you still stand to shoot yourself in the foot much more easily with threads. Much more easily with threads. It's very easy to shoot yourself in the foot with threads. That's why thread safety is so difficult. But as far as resource allocation, like namely CPU and memory, they are competitive. Cool. Fiber, explicitly cooperative in Ruby, provided by Ruby, provided by the Ruby virtual machine. Yeah.
So when you said they share address space, but they're competitive. So if you have a thread and you have this thread that's counting to 20 million versus the fiber counting to 20 million, the process scheduler for the computer is not going to let that thread just count to 20 million while the world waits, right? It's going to count one and then do a bunch of other stuff and come back and let the thread.
Yes.
But the fiber is going to count to 20 million while the world stops.
It's like Russian nested dolls, because the big box is process, inside process is thread, inside thread is fiber. So it's not going to do that because you don't have a fiber on its own. You have a fiber living in a Ruby process, and the OS is going to preempt that. Preempt is the term for when the OS is like, no, you've had enough cake. Like it's this other person's turn, right? The OS will preempt the Ruby process. Yeah. So
but anything in that Ruby process, you could mess up.
It'd be other fibers of yours.
Yeah.
So that's gonna be fun, and we'll get to it here in not too long. Other questions? All right.
Is there a limit on how many processes or threads can you spawn?
Let's see.
Great question. So can anybody think of limits that might be artificial or inherent? Does anybody have like a system administration background? Can you think of a limit, an artificial limit to the number of processes?
Well, if you have like, I don't know, 1 byte of memory to specify which process is running.
Well, that was what I was going to get to next. But just so you are aware, system limit on number of processes. And I don't have enough system administration operations background to explain why when you spin up a new Amazon instance, there will be a limit of like 1,024 processes. I think that you have to, let's choose Linux here, that you have to later bump up to suit your needs. And I can't answer why. So here's a fun thing we can do really quickly on my machine.
It's really hot.
Oh, 32K. It's pretty high. Like it's like, what's like a reasonable amount that somebody would need even on a server? 32K, that's a lot of processes, right? But you can also imagine with our big servers, even this computer has 20 gigs of RAM, right? It's multi-threaded, two cores. It's a beefy enough computer. You could, there's like a legitimate use case for having 100,000 processes. So there are these artificial limits that you have to configure in your system, and some systems might start smaller. But then it's what you said, David. They're real limits, which is the overhead of the bookkeeping, for example. Because it really is the overhead of bookkeeping, because you can always slice up the resources into smaller and smaller units until you can't. You know, if you have, you know, a gigabyte of RAM, you're probably not going to be doing something very useful with, you know, a billion processes that only get 1 byte each, right? So, but at the end of the day, there is bookkeeping the operating system has to do. It has to keep a table and remember somehow allocate resources. So that bookkeeping does have an overhead that is basically, if you go back to our notes, you know, we're basically starting with the most overhead to least overhead. So that's how you want to think about it. You can have fewer processes than you can have threads. You can have fewer threads than you can have fibers because they get lighter weight as you go down. Those of you that have played with Elixir, they have an abstraction called a process that is extremely lightweight. It doesn't bother the operating system. Who knows the word for when you have to ask the operating system for something? You have to make a system call. And why do we avoid system calls? They're slow. So let's see. I believe fibers, they definitely don't require a system call, which we abbreviate syscall. I think a thread, I don't think a thread does, but I'm going to put a question mark. A process definitely does. And the reason that they're slow is because the architecture of Unix, well, not the architecture of Unix, the architecture of the Linux kernel, which is not all that different than the Mach kernel in the Mac machines, isolates the system from the user, right? So when you run Ruby, typically it says the user, it's unprivileged, right? It's basically a model to help with isolating things for security and privileges. And the operating system lives over here, and it has all the privileges. It can do whatever it wants. Something like process management, for the reason that it's kind of clear now. Like if these things are competitive and you have a referee, the referee needs to have superpowers that the competing players don't have, right? So you try to avoid these system calls, and I don't know how we got started there. It was in response to a question of how many you can have. So definitely the overhead of system calls will get pretty obnoxious if you're creating new processes constantly, and it'll limit like the amount of useful stuff you can do. Other questions? Cool. So today we're just going to, I tweeted like Ruby is totally adequate for learning about these things because it totally is. We can just hang out in Ruby. We don't have to do any bash or anything else. We can just hang out in Ruby, and Ruby basically wraps the system calls. So you can write Ruby code. You don't have to leave Ruby. As far as I know, Python it's the same way. But if you do C, you'll be really glad to come back to Ruby because it's super much a pain in the butt. So I'm just going to open up, move this over one. Hey, Google. Not dropping the ball today. Call it process.rb. All right. And we can put, oops, what just happened there? Hello world. It's all good. Okay. Process. All right. So forget hello world. Hello from process. What goes in here? We'll call it like the process identifier. We'll call it master, the master process. I don't know if there's a I don't know if there's a proper term for what you call the process that process that's invoked from the command line. But so in really simple terms, what happens here when I type in Ruby process.rb and hit enter? What's going on?
To make a system call and launch that file as a separate process. Like we see in PS.
Yeah. I was going to skip that step, but yeah. Actually, I was going to skip that step because I think you're slightly wrong. You know, right here, I've got a terminal window. That's probably a process, right? And it's conceivable to me that when I type Ruby process.rb, that process executes the Ruby binary inline without forking. I think if you add a ampersand at the end, it detaches it, which requires forking. You can tell that I'm a real expert about this stuff. And we can play with this stuff later. Once we do the basics, we can come back and test. Because a lot of these answers, when I have a question mark, it's stuff you can test. You can just figure out by playing with it.
Is 6565 the process ID?
Yeah. Oh, so we totally have a, we totally have a Ruby process hanging around.
It's done now, isn't it?
No, we don't. Oh, because it ended, because it did block. It just, yeah. Yeah, so there was a process called 6565 that echoed into the abyss because it was detached. And that's a feature of the of your shell, the ampersand. Bash works that way. I'm running ZSH. That works that way. It's useful to know because it's actually a common thing you want to do. Like if I wanted to, open a graphical terminal with this file, that actually happens inline. So it's using that process. And now I can't do stuff here because it's using this graphical term, this gedit. But it's useful. Oftentimes you want to keep going, you hit the ampersand, right? And then we can, kill 6684. Right? This isn't what we want to spend too much time on today, but it's useful. All right. So we're running this guy, and Brad and I debated it. We don't really know, but it's conceivable to me that there's no forking yet. So let's do some forking. I'm just gonna wing it here, but rest assured that Ruby gives you a constant called kernel that has methods, and conceivably we can pass a block to kernel fork, and I'm just gonna def identify process here. Take this guy. We'll call identify process master. And then here we'll identify process first fork. Okay. Cool. So what does forking mean? And why is it interesting? What do we know about forking?
Multiple processes.
Definitely. In this case, I believe we created a second process, finally, which requires a syscall. Yes.
What did you say? I couldn't hear.
Multiple processes.
Oh, yeah.
Definitely. It's one of two main ways to get a second process in Ruby from the operating system. Why is it called fork rather than start new process or spawn?
Does it take what's happened in the program to that point with it when it works?
Yeah, it totally does. We can do like some state. Equal, well, let's do a counter. And the actual underlying mechanics of it. Okay. You can force it to be a global. Just because I don't know what I'm doing. All right. So that's how you force something to be a global, by the way, with the dollar signs. And I'm pretty sure that as soon as you use a dollar sign, it's no longer thread safe. Don't use global variables, folks. I just didn't know how to do it a different way. So there is some shared state. There is some shared state. So that's sort of to half answer your question, Anthony. This forked process somehow knew that the counter was at this point inside the fork, somehow it knows that counter is 1. Right? So there is shared state going on. How expensive is it to fork, do you think?
Double, you need like twice the amount of memory you have?
That's a very helpful answer. Yeah, the simple solution would just be to clone the process, right? But and this also I think goes back to the 60s or super long time ago. Basically, operating systems people are like, how can we make forking more useful in more scenarios and cheaper? And they invented something called copy on write. So that basically, when you fork, you just use the same address space until you try to write to that address space, and then it copies. It's pretty slick. I don't know how it works, but it's kind of a snazzy idea that means that we can fork more cheaply. We don't have to worry too much about forking, especially if we're just going to read a bunch of stuff. You basically get it for free. You don't get it for free. There's still the syscall. But you don't have to spend the time copying those chunks of memory, right? It's not just actually using the memory, it's the time copying it.
So when you forked it on line 1 there, that to do the counter was set to 1 and start incrementing to 2 because it kind of pulled down that shared state.
Yeah.
But it won't read backward, right? Like, so it kind of gets the shared state copied, like counter is 1 when it forks, and it gets that. It increments counter, cache counter to 2. But if we then fork somewhere else, it wouldn't pass.
We got to test this. I think you're right. We got to test it because, like, I never use globals in Ruby because you're really not supposed to. So what you can do, what we're going to do is just fork a bunch and sleep a couple times and just find out what's going on. So how about, I don't know, like what these friendly identifiers are going to be. Well, let's fork again. And here, let's sleep for 1 second. And here, we'll call it first level. So we're remembering, because we're doing this nested forking. I think that's a useful identifier, or it makes sense to me. And here we're doing a second level fork. Right. So this will sort of start to answer that question.
So if I'm
Right.
right, they're both gonna be, both of the first and second level forks are not gonna be two.
Yeah.
If I'm wrong, first level fork will be 3.
Yeah. Let's find out.
Okay.
So it's copy on write, and at the point that you write, which is when we're incrementing the counter, we're taking a variable, an integer in memory, and augmenting it by 1. Then it copies the address space over that it needs to. I think it's even smart. It doesn't even copy the whole address space. It copies like some subset, I think. So that was very useful. You know, I don't want to like get too stuck in forks. I think something that we absolutely have to cover is kernel provides in Ruby. Kernel provides a second method to do with creating processes. That's also totally useful. Does anybody remember this method? The method is exec. So we can do it. Let's do it here. We can just echo. To get started, we can echo foo. See what happens. So that taught us something very useful, actually, just there. I didn't have to use kernel exec to do that. But what this taught us is that these blocks do not block. Yikes. So I'm not going to go. Rest assured, these do end constructs in Ruby, or sometimes you see them with curly braces. That's a Ruby block. It's a chunk of code that you pass to a method. And unfortunately, and this happens unfortunately very frequently in technical subjects, like a piece of terminology will have multiple meanings. It's a noun in Ruby. We pass a block to a method. It's a chunk of code we pass to a method. And it's a verb in process modeling, in concurrency, whether or not something ties up resources and blocks other bits of code that live in other abstractions from running. So what we noticed is that at this line, at the point where this block, at the point where kernel.fork from 9 lines up, at the point that returns, it doesn't imply that the code in the block past a fork has executed, right? Because we saw the echo foo happen here, and then a second later, we saw first level fork. Does this make sense? Yeah. So that's pretty neat. It does imply something. Okay, so by the way, like, you see what's going on with this exec. You could do yeah, I don't want to do ls because I'm in my home directory. I don't know what sort of naughty stuff I have in there.
PWD.
PWD, thank you. Yeah, totally.
Can you do backticks to do that?
Oh my gosh, that's like a whole class. All the different ways to do that. Yeah, so I think that this is like the rawest way to do it, and all the other stuff is more useful and like higher level. So this gives you the most finite control. It actually doesn't give you the most finite control because that would be using like process open, but it gives you more control than backticks.
I just used system to like create some Postgres.
I think system. I've sort of settled on system. System's like my go-to one, but I can't even remember why.
I didn't. Yeah.
There is a reason I prefer system to backticks. Can't remember why.
I used that one time to execute some Java Node.js code and bring the result back from the
See, that blocks, right? I wonder if my shell has a sleep, right? So I could do something like sleep 3 and PWD. So let's test the sort of hypothesis you just suggested to me, which was we know that if you call system or backticks with Node.js, blah, 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 that the next Ruby line of code will wait for that node command to return. We know this. So I'm wondering if kernel exec does the same thing. So sleep 3, you can do sleep 2 and PWD, and then put end of file. Right. So this, if we see end of file before home Gabe, that differentiates it from backticks. So what exec does is doesn't fork, but replaces the process.
Can you try it with system instead of exec? Still.
Wait a minute. So it
Terminates the current process and replaces it very fast to exec.
It's like a very low level system call. It's like exec VE.
comes back.
That's what it does. And it's a useful, when you're doing systems programming, you'd be surprised, but it's like pretty fast where these things are useful to you. It's funny because it seems like not that useful, but it's actually like, these are like low level things that you totally need. Like you're totally like, exactly what I need is to replace this process with some other process. It's funny. Let's try, whose idea was that?
System. You replace exec with system if it still blocks.
It didn't block what we saw. It replaced the process.
Okay.
The end of file code never ran. We know with system it will block, and well, we never know anything. I think with system it will block, and then you'll see end of file. Yeah. Cool. So it's useful. So exec and fork are the two parts of Ruby core library, the two methods in Ruby's core library to manipulate processes. I think once you look into standard, the extended standard library, you get into things like process open, which is, it's basically like a fancier system call that takes more arguments. So you can do like play with standard in, standard out, standard error to your heart's content, for example, which is also useful. But we can totally skip that today because this is all you really need to know.
If you have a fork running and then you run exec, does it kill the fork or something? So for example, if you sleep
so
3 inside the fork rather than 1.
So I would think that this will not do anything very exciting. We will see end of file though, because it's only replacing the fork process.
No, but I mean, for example, if you leave the current fork as it is, but change sleep 1 to sleep 3, but then sleep 2 on the exec. Yeah, so like, and then line, yeah, no, that one should be sleep 1, and the other sleep 5 lines above to be sleep 3. So this fork takes 3 seconds to print.
Yeah, it should be totally happy. The fork should just be totally cool, and we still won't see end of file. Second level fork came through.
On first level fork as well.
Yeah, which makes sense. So we didn't lose first level fork by replacing the initial process, because by the time we replaced the master process, we've already forked. And then just to satisfy myself, I did want to, this should basically, we should see end of file now, because at this point we're replacing a process that is no longer the master process. You see end of file right away, because there's no sleeps in the master process. I'm pretty satisfied with this, like this exploration of processes. I was just going to see this. And let's move on to threads. We'll do the same thing with counter because that was pretty useful to us. Let's try it with the local variable counter. Just let's see, maybe it'll work with threads where it didn't work with process. I don't know. All right. Actually, I want to copy that that identify thing. It's kind of useful. Dollar signs. All right. You can do identify thread, master thread, and then thread.new. First level thread. Once again, this local variable solution is not working for us. Cool. So what if we create 100 threads at once? Doesn't that seem like a useful thing to do? That's what we're doing with like multi-threaded web servers. A request comes in, a thread from the pool of threads handles it, maybe just based on a random number. You're keeping a table of 100 threads, something like that. You just do this 100 times. We know from our notes that threads definitely share address space, but there's no copying on write with threads, I don't think. I think we're going to see the counter increment to 100, but the thread that increments it will be arbitrary because it's competitive, so there's a little bit of chance involved. I'm not sure. Whoa. That stinks. Okay. Well, gee. That doesn't make any sense to me.
So he's trying to run 100 threads, but it's only running one.
So we have to look at the API for thread. Oh, weird. The thread is blocking, huh? The thread is, no?
Is it the counter thing, not the
I would expect to see 101 lines of output here. Weird. Do you see that? What's going on? Put a sleep in? Sleep always help, right?
What? So
All
he
right.
was exiting before he was printing, maybe?
Oh, weird. You're right. Yeah. Thanks. So we have to. So that's part of the API is to say, hey Ruby, let's wait for those threads to finish. Right. So let's do that.
Also, we lost it because they were actually running over when we returned back to the shell.
Yeah.
Right? That's really funny. Is that what? Okay.
Yeah.
So
Okay. So this is pretty straightforward. So we can do threads equal. I think we can do that. I don't know. Threads dot each do thread dot join, something like that. Cool. So that basically we're saying, wait, we're asking our process, our master process, to block until the threads have joined. Oh, this is really fun. There is a totally interesting race condition. They're generally incrementing, but the order is out of order. That's right. Well, let's see. They are sharing that state.
So puts is like an idle call, so maybe that's where some threads.
That's a great thought. Puts may not block itself. Oh no, there's a race condition between incrementing the counter and putting the counter.
Tell me that maybe.
Or,
Yeah, so like, oh, sorry, what?
All the sides, it's interesting.
No, I don't know.
usually you can get rid of these with a very small sleep, right? No way, made it worse. Oh,
What about after instantiating the thread rather than the thread block?
good idea.
I mean, this is just an artifact of like the process scheduler. How do you do that?
It's definitely tied up with the process scheduler. Yeah, the same operating system component. Yeah. App is a nice way to take that return value and hold on to it. Yeah, the same system, the same part of the operating system that schedules processes. May or may not schedule threads. Actually, I'm not sure. It's a similar algorithm.
But every time Ruby is getting time scheduled by the OS, it's executing another thread, but not in the order that we put it on the stack. But that's kind of weird, right? Wouldn't it respect the order? That's kind of weird.
No, it wouldn't, because why does it need to?
Yeah, I know. I guess it does. Yeah, right.
If it can do it faster, not respecting the order,
Yeah.
so be it. Let's make this sleep a little bit faster. I'm guessing that was my first instinct. That should fix it. It did fix it. So all it takes is the littlest sleep, and we get them in order. So without Googling too much, are there other experiments we can do?
If you have a sleep inside the identified thread, then it's gonna lose order again, right?
Should it be bigger or smaller? Bigger. Yeah.
Or inside the function?
Shouldn't matter. Ooh, here's a fun race condition. Check that out. Super fun. So that's what you were talking about. There's a race condition between augmenting the counter at line 1 and echoing the value of the counter. So this is actually a really fun thing that we can deal with. I wonder how we can bring it about more so. We got it that time. We get it reliably. Why do we get it reliably?
Is there a sleep in between the increment and the foot?
There's a 78. We lost 79. Awesome.
And 76 is
That's so cool. All right. The reason I'm really excited about this one is that so it's not deterministic, because this time we only got 176. This is really fun, folks, because it's actually the question is, how do we solve this? Basically, this whole body, this whole method call needs to be atomic. Some people would say what atomic means in plain English.
1 entry point to the call, right?
Nothing happening.
But
We need to be able to pretend that these 3 lines of code are always going to be grouped together, that's what's happening, is that okay, so because of where I put the sleep is exactly why this is happening, which is awesome. We might be able to do something like, well,
I mean, you could just increment the counter in the foot statement, right?
getting rid of the sleep, yeah, but we want to use this as a learning opportunity. So there's a whole category of things that fix this problem. What is that category? Locks.
meters and
A semaphore. I don't want to get too stuck in here, but just see what comes up. Ruby mutex. This actually looks really simple. I don't know how robust this is, but it's a solution in pure Ruby that we can reason about that will solve our problem. Although I'm skeptical. Well, I don't understand how does Ruby's documentation get away with using local variables across there? Anyhow, we create our semaphore. And that's also I'm not sure how I feel about this documentation, because there is some subtle difference between a mutex and a semaphore, or a semaphore is a subset of mutexes. I don't know. If I were writing this documentation, I would do like my underscore mutex instead of naming the local variable semaphore. Anyhow, we can wrap those 3 lines of code in a semaphore in our synchronize, and that'll fix our problem. What else? What is the side effect of this?
Forward. Does that mean that no other thread can access counter until the one that has it open finishes? So then it's no longer concurrent at that point.
Yeah, this is a whoa.
do you have logos?
Fine. Let's come right back to that. But that's exactly right. So can we think of an example where this is still useful? Yeah, we can totally think of an example where this is still useful. Like if identify thread as something very expensive, like sleep ran 10. Not a great example. Yeah, anything expensive, it doesn't matter. The point is that you can still have a bunch of expensive stuff that doesn't need to be done synchronized, but in between those expensive things, you can synchronize. So this is a good opportunity for us to like peg our CPU and actually do some work. Forget about this. Identify thread. We're actually on track to have a really cool example. We've figured out how to create a race condition without the semaphore. Now we just need to do some real work and peg the CPU, both cores. Let's say before they do the work, they identify themselves. Let's to identify thread created, starting, ending. That might make sense to you. All right. So then we need a do work. Here, like I was just doing, we can sleep ran 5. Really don't know what's going to happen. Where do I, yeah. I'm just getting really, oh, yeah. Of course. So that sleep ran 5 was kind of silly. Why is sleep ran 5 silly? Sleep ran 5, is that actually work? It simulates work for the purpose of delaying the return, but it doesn't contribute to consuming resources on the CPU, right? Because the operating system can't be tricked that easily. It's like, oh, you're sleeping, we'll do something else. So you had a Fibonacci idea. Calculate Fibonacci up to a certain number. Does that sound good? Yeah, or copy and paste.
Here's a Fibonacci generator. It's
Fibonacci. See that it works. That's slower than I thought. Fibonacci of 100 is kind of slow. Thanks. I think we pegged the CPU. So the important thing is, obviously that's pretty slow, because if you just do, it returns right away. So Fibonacci, great idea. Totally slow, awesome. Thank you. The recursion is amazing because things get very slow very fast. So the important thing to notice here is whatever like the default sort order of my top. I just made it explicitly by CPU. By default, it does raise things to the top that are using a lot of CPU and memory. What do you notice is going on here?
over 100% utilized.
Where do you see that?
98 plus 27.
Yeah, that stuff's not very trustworthy. But yeah, good observation. What else is interesting here?
Ruby thread is taking up the most.
How much memory is not taking up the most memory?
What I noticed, oh, it came back, or it's starting to run out of threads. Whoa. That doesn't make sense to me. I don't know what just happened there. Okay.
As much as it can, it's being competitive.
It's being competitive. My computer's not slowing down. It's still responsive. You know, I can still go to the Hangout. Everything's happy, right? So good work, operating system. What I was noticing is that there's only one line item for Ruby, whereas there are many line items for like Chrome and Chromium. Or there's at least two for Chrome. You may know that Chrome uses a very like simple and effective model where every tab lives in its own process. At the time that they invented that, it was like super revolutionary. It's also very expensive sometimes with memory. We only see one line item for Ruby, right? So let's go ahead and Control C that and just go back to the process example. And we'll sleep this guy for 20 seconds. Sleep this guy for 15 seconds. We can just sleep them all for 20. It doesn't really matter. But if we sort alphabetically, because these guys aren't doing any work, we should see 3 Ruby processes for 20 seconds. So notice that there are no Ruby processes here. We should see 3 Ruby processes. Why? One got forked here, one got forked here, and one got forked here. But I'm not sorting alphabetically. Forget top. For now, we can just grep for Ruby in. You always see the grep process. There are my 3 Ruby processes. Cool. It was hard to get them to show up in top because they weren't using any resources. But rest assured, if they were using resources, they would show up in top. We can go ahead and do it. We can just put fun times over there. Gonna get rid of the master one because all we need is actually 2, right? We just want to see 2 processes. All I want to see are 2 processes. I want to see that they peg my CPU, right? So we can do inside identify process Fibonacci 1000, and we'll hit Control C. So they're detached because they forked, and they're not here. Huh. Forget the counter. Well, let's put this here. Answer Fibonacci 1000. There we go. I don't know why it didn't work before. So this is actually something we should have done earlier, because you can peg the CPU with any of these any of these mechanisms. But one thing you can't peg the CPU with on a modern machine is none of these mechanisms, right? Because every one of the laptops I see here has 2 cores, right? So if you're just running Ruby once, you're only going to peg 1 core, right? So I don't know why I see 4. Why do I see 4? Oh, I did start to slow down here. Oh, you know why? Because I ran to, there was a lag for them to show up in top. So I'm actually running 4. So now my computer's starting to get really slow, and we can learn something about top. Believe it or not, so Fibonacci 1000, who knows when that's going to return, right? Which is good. It means it's a good example. There's one thing we haven't mentioned yet with top that's sort of interesting. I'm surprised that we're not using more memory because we're doing it recursively. But what that tells me is that every additional recursion takes up so much more CPU. By the way, this is a terrible method because it shouldn't be this slow, right? We've all done Fibonacci before, and to get the remember how slow it was to do 100? If you do a fast Fibonacci, 100 is like pretty fast. I don't know how slow 1000 is, but this is not a great Fibonacci. But every incremental, the time required to calculate for each additional recursion is greater than the number of recursions. Because if the number of recursions was very great, we'd run out of memory because it'd be consuming stack space. All right, there's just one statistic here that's super useful. Can anybody point it out? You log into a server that people are complaining is slow. What do you look at? You do look at the CPU. You do look at the CPU, but what else do you look at? I'm not going to explain why you look at it. You're just going to have to trust me. You also look at the memory. What you look at is the load average. Is anybody familiar with this? I don't know how long this has been around, but basically we decided that what's important is to have this number on a rolling, it's like a rolling average. The first one is 5 minutes, is 1 minute. The second one's 5 minutes. The third one is 15 minutes. So it's sort of like these magic arbitrary intervals that we're calculating the rolling load average over. And I'm digging in my head. The load average is basically like, it's very subtle, but it's like, if the CPU were available, how many processes would want to run on it at that moment, right? So on average, over the last 1 minute, 5.1 processes would like the CPU to run them. And on average, over the last 5 minutes, 3.75 processes would like the CPU to run them. You can look that up again later. But it's useful because it takes into account things like how many cores you have. It doesn't actually take them into account, but you can very easily take it into account in your head. Basically, if the load average is greater than the number of cores, you're doing a good job of using your resources. In fact, you could argue I have 2 cores, a load average of 2 is kind of like perfect, right? Because I have exactly the number of processes asking to be run that I'm capable of running. But while we're on this subject, it's useful to answer the real question that you have. What's the real question that matters if you're operating a server?
What number too high?
Exactly. What's a healthy load average? Because all of us are super like economical, and like, you know, if the server still works with a higher load average, like that's cool, right? So I think the rule of thumb is 2 times the number of cores. So here we're a little excessive, right? And the reason we're seeing higher than 4 is because Google Hangouts requires a fair amount of CPU. And I think if you were to ask me why is the rule of thumb 2 times, it's because as you go over the number of cores, the overhead of the operating system having to referee these processes cuts into the amount of resources that you can use to get real work done, to the detriment of your system. So load average, super useful. And it's also easier to understand. Like I never understand like what does this mean, right? Because yeah, you can add these up and it's over 200, which makes sense because there's 2 cores. But I like that the load average can be like summed up. This is what it means at over this period of time, on average, how many processes wanted to be run.
And it's creeping up, so the performance is degraded over the time.
I'm sorry?
It's been creeping up, so there's bigger more backlog.
Makes sense.
Totally. Yeah, maybe that's because like the iterations of the smaller calculations for Fibonacci were tighter. So like the operating system would preempt in between method calls, but it doesn't want to preempt during a method call, so they build up. I'm not sure. So that's pretty good. Do you want to we peg the CPU with processes? How do I stop the CPU from being pegged? Yeah, kill all Ruby. Awesome. You start to see this guy plummet. Yeah. Cool. So we're back happy. So I'm leaving process.rb. We saw that you can use processes to peg your CPU, even though you're only running 1 command. And we already were on track to see this. But we can do Fibonacci 1000 here. And let's just get rid of the sleeps. Forget it. We don't need them. Forget about the synchronize. You know, let's let the work be the work. Let's not create extra nonsense. And here, our load average should start going up again, but it's not. So the
Why is it taking so long to create new threads?
Wait, I'm confused. Does it create the threads when it's doing the intertimes map and then execute them on join, or does
As soon as you create the thread, it starts.
but on thread.new it starts?
Yeah.
So then what is join doing?
it blocks
waits
until the
until-
thread returns
It blocks
the master process.
Okay. The program that's running.
Well, I am stumped, folks. We just started 1,000. We started 71 threads that are all calculating something that we know is very expensive. Yet we're not able to peg the CPU.
But the CPU is like, for the Ruby process is like 99%.
Yeah, but I'm looking at the load average. So you're right, but there's the whole
It can actually execute.
Well, according to George. You know.
So what Brad found on Google is that MRI is limited to one thread at a time.
C Ruby has a global interpreter lock, so it cannot run threads in parallel. There's another person who does the same thing.
Global interpreter lock.
So why do we use multiple threads in C Ruby? Like, why is WebRick even multi-threaded? It's because you can run it in other Rubies.
Well, you could still get,
For concurrency, right?
I mean, you could still get concurrency on a single processor core, right?
Like to handle the request.
I mean, it's sort of fake, right? Because I guess.
Oh yeah, that's exactly why. Thank you.
I mean,
It's not fake. It's not fake. We're able to peg the CPU even if, you can look at it like this. Thank you.
It can't actually happen simultaneously because there is a scheduler on the chip, but it'll seem like it's just like JavaScript, but it'll seem like it's not.
We can do like Fibonacci 75, sleep 0.01, Fibonacci 75. Demonstrate this. Thank you. That's the answer. The answer is that without threads, if there was any blocking IO,
It'll just sit there.
right? Exactly. So we're using this sleep for 1 millisecond to represent like reading something off the hard disk, reading something off the network, and by using multi-threading only on a single core, we can still peg the CPU. Do 1,000 threads because I don't want to waste our time. I want to demonstrate. Well, let's do 10,000. All right, 1,000.
And Python too, FYI.
So we hit 100. We were able to peg the CPU, even though we have this blocking going on at line 6. If we were, I feel like I haven't persuaded everybody, but that's the name of the game, is lots of useful programs. Part of the program is blocked, waiting for network or waiting for IO, and you can use threading to accomplish many tasks at once that are partially blocked and use
Maybe
all your resources.
The sleep was like 10 seconds instead. I mean, because if it's 10 seconds, then you have a lot of threads waiting, while some threads are computing. But if the sleep is too small, then
Yeah, so pretty soon we should have 10,000 threads sleeping. 10,000 threads sleeping takes how much CPU? None. So good idea. So we have 10,000 threads sleeping roughly, but we actually thank you.
But I also think that some of them are Fibonacci in the first pass.
Yeah.
They're all Fibonacci in the first pass.
I know. I'm trying to think of it's really annoying because I don't know how long Fibonacci takes.
Maybe Fibonacci like 2 or something. Above and line 1.
Fibonacci 10.
It's gonna run as long as you want more and more precision, right?
Do Fibonacci rand 20. Run as long as you want more and more precision of the more and more Fibonacci's, or
We use series, finite series, infinite series to emulate, trigonometric functions and that type of thing. If you want a 10-digit response to what some trigonometric function is, or some value of an angle, you're gonna run it as many iterations or as many recursions as it takes to produce that number of digits.
right? In our case, we're specifying that we want to run it for rand 20 iterations or 75 iterations.
You're gonna count the iterations or the recursions instead of looking for a specific number of digits.
Yeah, exactly.
It's okay.
I'm convinced. But thank you for pointing that out because I was surprised. I forgot that that's one of the things when people poo-poo Ruby and Python, they say they suck. This is what they're talking about. You can use threads to use all your resources available in light of blocking IO up until you need to use multiple cores. And if you hear Jose go on about Elixir, he points that out as an advantage. Use all the cores for free. Whereas with Ruby, and that's a real thing that people do with Ruby, they distribute a multi-threaded server across 2 processes, which sucks because it's just more moving parts. Right? I'm going to Control C this, and
multi-threaded server across 2 processes, so it's multi-thread and multi-process.
yeah, we have to do this.
In order to use both cores.
Yeah, and we still benefit from the multi-threading because, like, there's a very famous web server called Apache that for the longest time it created a process for every request, and like it worked super well-ish, like because there's a lot of overhead to that. It means for every concurrent request that you're serving, it's an extra process, a lot of overhead. So by mixing processes and threads, we have a nice balance. We get around the crappy side of Ruby, which is that you need multiple processes, which is that you can't have threads across cores, but we still benefit from the less overhead, not requiring a system call to handle a request, for example. So all of this stuff has been competitive. Yes, Joe.
Somehow I missed, and I see it here in your class, your whiteboard. Elixir basically redefines the word process. How are Elixir and Ruby related here, please?
We had been talking about Elixir earlier, and basically that was in context of the preceding sentence, which is that
Provided by the OS in Ruby.
in most cases provided by the OS. Basically in nearly all cases provided by the OS. But what I didn't want to happen is somebody.
But then the threads aren't provided by the OS, are they? They're provided by the virtual machine.
They're provided by the OS, but at a different level. It doesn't require it doesn't require a system call. It requires asking a shared library like pthreads. Fundamentally, it's like I don't know what it is on a Mac, but it's like a GNU userland library. It's part of like libc, I think.
So the C Ruby interpreter is reaching out and calling that thing.
Yeah, it's just linked against it's like dynamically linked, or basically it's shared. It's in the system, right? But it doesn't require a system call. But it still qualifies as the OS. It's just a different part of the OS. OS is sort of like a broad term. So our processes are always provided by the OS, except with Elixir, which redefines the word process. So in the context of Elixir, no, a process isn't provided by the OS, but it's a totally different thing. That's what I was saying, Joe.
We'll call them channels.
Or Go routine.
Go routine.
They're called them routines, not channels. Channels are the communication.
Yeah.
All right, so WTF fibers, really fast. So what we notice here is fibers are never preempted. Fibers are never preempted. So the only reason threading works is that they are preempted, right? If the threads weren't preempted, then during the sleep, it would block, right? But the OS does preempt them. So let's play with fibers. So it's very easy to see that something's not preempted, right? We can just do 100 times. Fiber.new. And inside fiber.new, will yield the number of the iteration. And in fiber.new, we'll sleep 1 puts fiber number iteration. And if I understand correctly, what we should expect to see is fiber 1, fiber 2, fiber 3, right? Because they're not preempted. We don't see anything.
Oh, you need to wait for them to.
Yeah.
Then you need to press the.
Oh, you gotta.
For
Thank you. They're not preempted, right? So we're not gaining anything here. The power is ours to do something smart, but we have to do it.
And how do you like assign 1 millisecond of execution to a fiber?
I have no idea. Let's just check it out.
Yeah, it's because it's so terribly useful, because if it blocks in the fiber, it's gonna block everything anyway.
It is useful because it's lighter weight. If you know exactly how they're going to cooperate, like if you had a task A and a task B and a task C, and you knew that that each fiber was going to do A, B, and C, you can program it so that they concede. Concede, is that the word? When you give it back, yield between A and B and between B and C, and then they're done. So if you know statically from the onset exactly what the ideal use of resources would be, and I'm having a terrible time thinking of an example. If you know it, you can just program it, and it will be deterministically always that way. And by doing so, you give up the overhead of having to do any sort of algorithm to share resource usage. You don't even have to count the resource usage, conceivably, right? So less bookkeeping, less overhead to calculate who's up next. I'm having a terrible time thinking of an example. But what it requires is cooperation. It requires an omniscient programmer who's in control.
Oh, no, so yeah, no. I think the idea with this is that the person making the fibers essentially decides when they run and when they jiggle.
Yeah.
So like when the fiber maybe makes an IO call, then the fiber can like jiggle.
Yeah, let's do that.
Oh, yeah, that's what you would do, so you would like do a bunch of stuff, do a long thing, yield,
Yeah.
and then come
And
back.
so, a little fiber would-
So you're basically doing all of the work of the schedule.
Yeah.
So you're only gonna do this if you think you're better at it then.
And it only works because you have control.
Yeah, totally. Why is this group? This is really minor.
For fiber.yield.
What do I have to pass to? Oh, thank you. It's useful, Brad, for doing like systems-y exercises without having fibers. If you wanted to do a prototype scheduler in Ruby, you'd be effed because the only abstractions they give you are you lose control. With fibers, you could, as like an exercise, write a toy scheduler.
So if we wanted to re-implement an operating system, it would be super helpful. No, that's interesting. I wonder if Zeke, the Zeke guy, is
How do I do something after yielding though? So we saw that yielding worked.
Yield takes a block.
So when you resume a fiber, it's actually getting executed rather than when you create an instance. Right?
Yeah, so maybe I can do it again. I'm just guessing here,
Yeah,
folks.
yeah.
Yeah. Cool. So that's the purpose of fibers.
So it's like a state machine, kind of.
How come it's sequential in the second part? Oh, because the sleep is right there. So if I do it 3 times, then we should be fully utilizing our CPU. Right now we're not because I forgot to yield a second time. Nope.
Now it's waiting 100 seconds, and then it will print.
Will you guys help me fix this? So I was bummed out that I would expect after 1 second for them just to all spit back. How can I make that work?
To all split the after print statement?
Yeah.
Or?
And why didn't what I just do work?
No, because each fiber sleeps 1 second, and then the next fiber sleeps 1 second, and then the next fiber sleeps 1 second in synchronously, not all at the same time.
Oh, it's just inherently sequential. There's no way around it.
I mean, maybe there is a way to assign. Yeah, I don't know how can you assign a tiny fraction of the execution. Or something.
You make a new fiber and sleep in that fiber and then yield it.
Yeah, exactly. So so it's more like this, folks.
That's what you could you so you could put the sleep. Oh, sorry.
No, really.
I mean, I don't know if it's like that, but if you had the sleep, you could put the sleep in a new fiber, call yield, and then call sleep, and then sleep will happen silently in the background, right?
No, because the fiber will.
No, then it'll come back. Yeah, you're right. Yeah, totally. So yield just lets it be interrupted.
Yield, yeah, and also allows for the fiber to send something back to the caller. So you can yield.
Oh, yield.
I guess in this case you can
okay,
yield
yeah.
a number, and then on the main process you can catch that yielded value
Yeah, cool.
when you resume.
Yeah. So
That's interesting.
So here's a quick and dirty way to make this seem somewhat useful. We could do like if I dot even sleep, right? At least then we'll see some afters come through. If you're on.
No, because you
Oh,
have
you're
to wait
right.
until all the
Yeah.
fibers resume, and then. Or you could create a new thread inside a fiber.
Yeah, what happens if you do that?
Let's wrap up. Fibers are like probably the one thing it's okay to be a little bit fuzzier about because they are unto Ruby, so they won't necessarily carry over to any arbitrary language, although many languages do have this feature. And if you want to model a scheduler in Ruby, this is the only tool that's up for the job until you get into like the evented model or the actor model, which is up next, folks. We're gonna do actor model, evented model, probably just one more class on this stuff. Really excited about that. And another class idea that I have that I think I was going to do with Niarika is like on like something about like interviewing at companies, something about like making yourself like an awesome candidate, because both of us are recruiting right now and we have all sorts of tips. So maybe I'll do that. Maybe I'll do this one December 29th and then that in the new year. In the meantime, I do want to get some feedback from everybody. I wonder if Alex is still with us. I wouldn't be surprised if Alex left when the Hangout died, but Alex is still here. Hope you've enjoyed this, Alex. Hope that the little gap didn't bother you too much. So feedback looks like this: things that went well, things that didn't go well, suggestions for general improvement, and suggestions for topics. I'll go ahead and start the topics with actor evented and actor-based concurrency and job hunting. I'm just gonna go around the room. You don't have to give me, I'm just gonna ask each of you to give me one positive, negative, or suggestion. Typically, if you give a negative, which I would like you to give, it'd be great if you could express it in terms of like, this is what I think could be better, and here's a suggestion for how to make it better. Donald?
All right, it's like, for me, so whenever I come to the class, I always going to use stuff from the class. I don't know about the kernel, the
Management in Ruby. Anthony?
Oh, man.
Brad?
Yeah, the subject matter is super cool. They're good choice of subject matter. And the only feedback is, I'm curious about like practical use cases like in like the Rails. But when would I reach with Fred.new, like on the day-to-day of building Rails apps? We covered that a little bit with the server. Like,
Yeah, totally. But
You're
it's
running-
just nitpicky, right?
yeah.
I'm like, yeah, because I don't write server.
Just maybe other applications.
So really quickly, I'll just, I meant to like mention this at the beginning, but really what I'm working on that I need this stuff for is super boring, but also super useful to everybody, or like you're gonna come across this too, which is just making a bunch of HTTP requests concurrently. Like, let's be honest, like that's a useful thing to do in a number of circumstances. For example, if you're like a sleazy hacker that wants to like blackmail some company, you can DOS their network until they give you money, and that would require concurrency because you need to make many HTTP requests in parallel, right? Or you are querying an API that's a robust API. It can take the traffic, and you want to suck a bunch of data out of it. In my case, I'm trying to suck a bunch of data out of Facebook. It lets you batch calls up to 50 in one query, but that's it. And of course, Facebook has a very robust backend. They can take what I can throw at them. How am I going to do it? You can totally do it with threads. But there's also, you can pretty much each one of these, there's a solution with each one of these. So that was sort of something I wanted to talk about because I was comparing solutions and pros and cons of each for such a simple use case. There's gotta be like a best solution for me making all these Facebook requests. And that's why I wanted to explore this stuff. So that's an example, like a very simple example that we all have to deal with every so often. And I think maybe with the class, with the class on the vented or actor programming, we could use that specific example because it's similar to how you demonstrate front end frameworks with like to-do lists. You can demonstrate concurrency with HTTP requests. And everybody needs to bring a server that we can thoughts with your permission and that of your infrastructure provider. Thank you, Alex. Yes. To be truthful, like when I logged on this morning, like 4 people were signed up. And I definitely did not, I expected to see 1 person. So therefore, and we're all busy, as you can imagine. I just like the cost benefit wasn't really strong for me to like spend a bunch of time boning up on this stuff. So a lesson to everybody is if you could RSVP a few days in advance, I can spend, an hour or 2 testing this stuff out. So I'm not just showing up and typing away and see what happens. Although it was fun, and I felt like it was fun for everybody. Like we weren't moving super slowly. We Googled a little bit, but we also like, I don't know. I thought like this is actually a pretty good learning for me as well as you folks. That being said, it could be better, and I would like to do this class again, maybe next year, and prepare a little better and have like better motivating examples for each one. Joe, do you have any feedback?
Since I've just learned how to sign up and get on the whiteboard, yes, this is looking very promising. But as I said, I'm an old guy who's a noob. So this looks like a great start.
Almost done. Not Greg. Dennis. I'm sorry? Another Alex. Welcome back.
Sure. I don't really have any suggestions. It was pretty much over my head. That's great. That's why I was interested.
Alex is an old timer a little bit. You came, yeah, exactly. It's good to see you folks. I said that to Anthony earlier. It's great when people like. There's no pressure. You can take off as long as you want. Do whatever else in life, and then come back. And we're always really happy to see you. Do you have any suggestions for topics that would bring you back?
Well, I was thinking of everything.
Vim.
So, I've tried to learn Vim over the years, and usually I just get bogged down in the commands.
It's all about this game, man.
Yeah, that's a ticket. I'm serious.
What you got to do is present like a line item in the budget of your job, like I need 20 hours a week to learn Vim, and I also need a budget of $25.
It's like the cost benefit. Like I'm so handicapped by Atom or Sublime, and they do all I need. So.
Don't they ever crash on you? I've totally seen both of those things crash.
Actually,
It's never had.
It's not
It's
great.
Yeah, sometimes.
Which is great.
Sublime Text is not a handicap. It's great.
I've seen
Nothing else.
I've never had a crash.
Atom crashes.
Adam
With large text, large files.
Nothing against Sublime Text. There's Vim key bindings for it.
That's what I was using before I switched to Vim.
I've been using Atom.
Sublime Vim.
It's just, I think it's like generational.
I don't think so.
You don't think so?
I mean,
I use Vim.
I've seen great programmers using Sublime or great programmers using Vim. So it's not the tool. It's like the right tool for each person, but I don't think in general.
I've even heard of a pretty good programmer using Emacs once.
Yeah.
That was too easy. Sterling.
My suggestion would be at the very end cover some libraries or some gems that implement the core concept that we learned. Just as a way of.
Oh, that's a great idea.
Just a way to say like this is how you would.
These are real implementation.
Yeah. This is like how this works. Is what we discovered.
Yeah, that's a really good idea because that'd be if I just came up with a quick list, that'd be a good place to get started.
If you look at the source, you or for me, it's easier to understand what's actually doing after having this.
So an example of something that is for those of us that do Rails is being familiar with whatever they call it these days. It's called Spring. We used to use something called like Spork or Zeus.
Yeah, for test.
And now, no, it just makes your development cycle faster. Yeah. And now it's built into Rails, which is great because it means everybody's using the same thing. So we find all the little obnoxious bugs and document things better. But in order for Rails development to be fast, because Ruby's so slow, especially starting up the VM, we have to keep like a hot version of the VM ready to fork every time you type RSpec. And I actually find it pretty useful, but every so often you have to kill it when it gets confused. And sort of when debugging these things or understanding why we jump through these hoops, it's good to be familiar with like copy on write and forking ahead of time, just so that it's all ready to use, which we didn't actually talk about, but I think that's how Spring works. To save even the time, you don't necessarily, it does a system call in the background ahead of time so that when you type RSpec, the fork is already ready and doesn't need a system call. I'm just riffing off of your idea of like, how is this relevant / where could I look for implementations? The Spring source code probably points you towards a lot of like the snakes that you run into with the process model, for example. And you're the last one, David.
I think an improvement could be sometimes for example, when you were looking at the top output, you stopped for like a minute to figure out what was going on, and everyone was like, I don't know, waiting for something to happen.
I think I was trying to verbalize something.
Yeah.
Pause to gather my thoughts. By the way, it would have been a lot more awful. I would have done that so much more often if you folks didn't like volunteer answers and just shout out at me. So thank you. That's really a positive, a huge positive. People shouted out answers.
And I was actually just
when I couldn't remember
kind of related to that. It was nice to have like literature to read in advance because then I could come prepared, and everybody can as well, and help in the decision making process of how things should be done. Because when you come in without knowing what's going on, sometimes it's even worth it to know so that you might decide to not come. Like it might be something where you're like, yeah, you know what, I can sit this one out.
I'm glad you read it. Like I definitely, everybody benefits when we put that investment in on our own time. I did feel a little bit sleazy giving you 3 Wikipedia articles.
Oh, they weren't even that big.
It's not that they're big, but it's just like,
reasonable.
it's just not tuned for like the content. Like it'd be cool to have something. Well, I guess it worked out pretty well. So,
It's kind of hard to read.
I'm going to note that down, Anthony, that actually the Wikipedia articles weren't that bad. They were still useful. I always feel like bad about that. All right, Joe.
Naive question here. Is there a standing syllabus that you're adding to, or are you writing the syllabus as we go here?
What syllabus?
Thank you. We're writing as we go.
We've done repeat classes. Samir does beginner Ruby and Rails that are repeat, and he has a syllabus. But every so often we have things that are more structured. But I think we tend away from that. Well, you all have been super wonderful. Thank you for joining us today, and I hope to see you again.